Welcome to video 10.7d, Inscribed Parallelograms. So here's the theorem. If a parallelogram is inscribed in a circle, then that parallelogram must be a rectangle or a rectangle from the previous story. Okay, so here's example 3. Given circle O, EFGH is a parallelogram. Oh, it's inscribed in the circle. It must be a rectangle or a rectangle. HG is 120 degrees, OJ is 6. Find the perimeter of the parallelogram. Okay, so let's label. HG is 120 degrees. So 120 degrees. OJ is 6. I'll just go like that. And I've already said it's a rectangle because it's inscribed, a parallelogram in a circle. All right, so, well, if I were to draw an auxiliary line, I think that would be very helpful. Let me just dash it for you. Oh, I've just drawn the diagonal of that rectangle. The diagonal of that rectangle is really going to be the diameter of the circle. If the radius was 6, 6 and 6 make 12 for that whole length of the diagonal. Oh, angle, let me just use these. Angle HEG is an inscribed angle, and the intercepted arc is 120 degrees. I think the inscribed angle is half the intercepted arc. So angle HEG equals 1/2 of 120 equals 60 degrees. Oh, if I've got a right triangle and you're 60, then this must be 30. Oh, I've got a 30, 60, 90 with one side. I can use my ratios. So I'll just redraw that triangle so you can see it more clearly. All right, so we've got a 30, a 60, and a 12. So you're going to be using these ratios and Pythagorean triples all year long, so you better get used to it. So I think opposite of the 30 we called x. I think the hypotenuse was also always 2x. And then the other side was x radical 3. Okay, then I just set up the equation, 2x equals 12. So x equals 6, which I can solve easily. All right, so x equals 6. And then this would be 6 radical 3. Okay, so 6 radical 3, 6 radical 3. So now the perimeter is going to be 6 plus 6 plus 6 radical 3 plus 6 radical 3. Now you got to go back with adding like terms and radicals. So the 6 and the 6 is a 12. And then what's 6 dogs plus 6 dogs? 12 dogs. So 6 radical 3 plus 6 radical 3 is 12 radical 3. Didn't give any units. Always give the answers in exact simplified form unless otherwise specified. So that would be the answer. So there you have it, a cool example based on a cool theorem.